This is the screencast for the February 1st computing meeting. We're just going to go through sort of developing a task and showing where the main files are and that kind of thing. Yeah, okay, so we've got it plugged in and it's blinking. That's good. Now, the first thing we need to do is set our configuration, and you only need to do this once. So we have a couple different setups here. So Launchpad 0.3 and 0.4 in here, and this will show up like when you download the project. And actually, the easiest way is to just right-click in there and go to where is it? Build configurations, set active, and then this one is 0.4. Most of you guys are going to be using 0.4.
This is a 0.3.
This is a 0.3. Yes. Okay, it's right. That's why it works. Okay. Yeah, so 0.3. Most of you guys are going to be on 0.4, I'd imagine. And the other thing is, so right-click, properties, and general, I believe. Yeah, so the debugger type you're using, probably going to be the JLink. If not, it'll be the XDS100v3, I'm pretty sure. But that's fine. It's one or the other, really. And it should be set already. Okay, so now the main file, like where everything gets started, is under source. And then sysmain.c. So it's a little bit of a mess right now. Stuff at the top, don't worry about that. We enter main kind of a little ways down. Then we just initialize everything. So serial, GPIO, and SPI. We'll eventually add an ADC in here. And I guess I can show you how to debug now. So to add a breakpoint, which is where it'll run all the code up to that point and then stop there. And this is really useful. I'll show you how to use this to like check variables and stuff. You just sort of click in the side there and you'll see a blue dot. And then to actually debug now, hit the little bug in your toolbar, and it'll connect up, it'll build, and it'll flash the code.
So if you get married, people will not wear
Oh, we got some red. Uh-oh. Okay, well this is good. We'll fix a problem live. Oh shit. What's going on here? One of our errors, we reached the limit of number of errors, so okay. What's happening here? So if you don't see this problems thing, I mean, hopefully you never see it, but you're gonna see it. It's window. Where is it? View. Is it like view other? Okay. Come on. View, general, and then problems. Sometimes it'll just like delete a like window thing that you use a lot, so you need to know how to bring them back. Okay, so what's going on? Steve been tinkering with this. First define. Okay, so I think one very common thing is when it builds, it generates a lot of stuff, and I think it's probably just it's seeing a bunch of old things. So right click and clean, and then that'll flush out a bunch of old stuff. And this is sort of the first thing to try if you're getting like weird build errors and stuff. Is like if it's like forgot a semicolon, that's not going to help you. But if it is something like stuff redefined or defined twice, that's probably going to fix it. Derived resources. Okay, I've never seen this. What is going on? Shit.
See, I told you it always happens around me.
Yeah. Okay. What is going on? I wonder if Steven played with this. Dual config 0.3. Just gonna see if he.
Something to blame.
Yeah. Well, no, he was like he's setting it up so that we don't have to like regenerate files a lot with like different boards and chips and stuff. And so that involved moving a bunch of things around. So it could be that, but I don't think I've ever pulled. So it should just be my own stuff. Dual config, yeah, no, that's just me. Okay, I only got myself to blame for this one. That sucks. Okay. That's weird. To me, it seems like a build clean thing. 0.3, that's all fine.
Yeah, just like walk. Just like get that third experiment and you finish it as like wasn't this done yet? Wasn't it? Third experiment's the one we get the wave from, right? Something like that? Yeah. After that, everyone hit a wall.
Oh, okay. So I think it's a little weird that this is happening, but so we have things defined in multiple locations, which it doesn't like. So this is for the configurations that we have. So we want to be on 0.3, and it's picking up stuff from 0.4 and also from prototype A. And these folders just are where it throws stuff when it builds it. So you can right-click the folder and exclude from build. And we'll do that for that one. And we'll do it for this guy too. Try that now. Okay, so it built, that's good. Just see what our warnings are. Some of these are normal. Okay, yeah, that's normal. Okay, sweet. So we can build. So that's step number one. Now we can debug. So that breakpoint is still there. So we'll hit the bug. And usually it'll... Okay, so it's just going to flash it. Okay. And so the debugger has put us at the start of main, and it's paused. So you can see we don't have any blinking or anything. And sometimes you need to bring your breakpoints in again, like that. Like if they're grayed out, I don't know why it does that, but it does. So now we can run it up to this breakpoint, and it'll stop there by hitting the like play pause. And you can see, so we've had GIO init run, and what that does is turns on this LED just as a default. So we can see like stuff's definitely working. And once we run again from this line, it'll actually run that line and then keep going. So the other useful thing is to have a serial terminal just in your code composer so you can see what it's sending out. So to do that, you go to View, I think, and then Terminal. It'll pop one in one of these tabs somewhere. Now we can connect up. So hit the icon there, and the settings are. It should be pretty obvious. It'll be USB serial dash something. And your baud rate is 115200. 8 data, 1 stop, and that should do it. So it looks like it's connected. So when I run this, we should see SFUSat started pop up there, and then it should start blinking and stuff. Okay, good. And now what it's doing is this is actually all the testing we did at Triumph. And interesting to note is this number here is the RTC time in seconds, although it's not increasing, which is weird. That might be a bug to investigate. Anyway, that should be increasing. The way this test was done is it was kind of shitty, so this could totally be happening. So that's not too concerning right now. But anyway, things are running and we're good. Does anyone have any questions about that? Okay. Yeah, it's just sort of procedure. Usually it'll work. Like once you get it going, it's pretty reliable. Okay, so we did a lot of this will all be cleaned out. It's kind of a mess right now. But the main thing is the first thing, like RTOS thing we do, is we create a main task, and then that task creates everything else. So we can go find task main. That's in SFUSat is where we keep everything that we change as much as possible. And SFU task main.c. And so I'll make this text bigger so you guys can see it. Here's okay, it's pretty big. Full screen and stuff too. Okay, so this is the main task file. So let's say you need to add a task for doing something. Generally, just sort of follow the example of what's already here. So we already have an ADC task created for some reason. Let's make a new one. So type name, so ADC new handle. So we'll keep going and copy the other stuff that we need to do. So this is creating the Blinky task, and we can go look at that in a sec. And then we've got a bunch of stuff commented out, and we have one for serial, so that's the one that'll constantly print stuff to the terminal for us. And then we have one to read and write to the flash memory. That's just for testing purposes. And then this is some magic Steven stuff for being able to send a command. So let me actually try that. Don't know if it's totally set up for it. Actually, I don't know if I can type into that terminal. Anyway, we have a few commands so that you can issue it, and then it'll send back various things. So when it's all enabled, you can ask for the state. So like low power, main, or safe, I guess. You can set the state, so you can tell it to go to low power, things like that. You can get some info about like the number of tasks it's running and things like that. I think there's a document for that somewhere.
Are they like pre-built tasks, or are they ones that you guys made?
It's all stuff that we made. And there's a procedure for like adding a command. And when it picks up a command that we sent it, that will generally create a task, or like create an instance of a task, and then it'll start running according to the priority and all that. But it will be sort of shoved into there, and then it will get to it when it should.
Okay. That's RTOS stuff.
That's RTOS stuff, plus a bit of our stuff with the sending the commands is all us.
Right. Yeah. The logic of like it being kind of like queued though is RTOS
stuff. Yeah. And I think we have a command to like change the priority of a task. So the way it ends up working out is each task that you create ends up having an ID. So you can just say task 13, set that priority to whatever, and then that could potentially make that task want to run immediately because it's a very high priority, or we could basically turn that off. I think we can delete tasks and stuff too.
Okay.
It's been a while since I've messed with that. But that system is all there. Works fairly well, and eventually that'll just be tied to the radio. So we'll be pulling in the data over the radio, decoding whatever those commands happen to be, and then yeah, that's really how the whole thing works. Yeah, so doing something like adding a task is a little confusing the last time I did it, but I hadn't wrote that system, so I didn't really know what was going on. But it's like dealing with any system that's already sort of up and running at work or with this is really just looking at the existing code and using it as an example. Because a lot of our core functionality we have, like being able to send a command and for it to execute and stuff. So just adding a new one is just copying what's already there and then calling your function instead of whatever it does already. So that's really the main thing. But I mean, I'm sure there'll be issues of like, you know, we have limits in place for like how frequently it'll send stuff out into the terminal, and like we need to increase those because we've occasionally butted up against those, and issues like that will be a little more tricky. But just sort of the application development shouldn't be too bad. Okay, so yeah, it's just doing some stuff. There's also a thing in place where we can schedule a command. So this is actually what this test does is it says, so there's a command called get heap. So that returns the amount of heap, number of bytes of heap space left or used, one or the other. And this is just a test that's always been in place. Don't really need to be concerned about the syntax, but once that stuff comes up, it schedules that task for 6 seconds after the whole thing gets going, just as a test. And so I think assuming that's all there, we can try it again. We'll just hit the hard reset, which is labeled. So it's going to start out, it's going to do some stuff, and then in a couple seconds, yeah, I think that was it. Is it? Oh, here it is, yeah. So it did these various things.
It's a function, or it's a command that you can call whenever it goes through the terminal?
Yes. So this terminal, I don't think you can type stuff in. It's weird. But there
And
we
I think the
use a
keynote speaker is
different
some
terminal,
sort of
like the
document
Arduino
that,
terminal.
Right.
that's like I'm putting like 3D printing into like space.
Couple
Yeah,
of
yeah,
commands.
whatever you said.
I forget what I normally use.
Like
It's just like, but anyway, yeah, the command system when it's all enabled and stuff works pretty well. It's pretty cool to play with. So,
yeah, and then I think we can make some good connections there.
let's go with continuing our ADC task example. So the first thing we've done is that we've created a handle for it. Now we need to create it, so we'll just copy what we have here, paste that in there, and the first argument is the function you actually want to run, if I remember right. Should be. So we haven't written this function yet, but we'll do ADC read. This argument here is just for us. It doesn't actually get used at all. So this one here is the amount of stack that the task has. It's not really something that you can predict in your head, probably. So rule of thumb is like leave it at a couple hundred, and if stuff is going weird, increase that number. That's really all you need to do. We have a lot of things. So this is the priority one here. We have a lot of macros all over the system. Just to kind of keep things all consolidated. So you can right click and go to open declaration for pretty much everything, like functions and all that stuff, or macros or anything. You can see we've defined a bunch of priorities just outside of that, just so it's easy to change because they're all in one place. So priority of 4 is probably fine. And then this is the address of the handle we created, so we'll figure out what we ended up calling that. It's this guy. Place that in there.
Two things have the same priority as before. Does it just do it in sequential order?
Yeah, it'll depend when they need to get called based on the delays. So let's say you want to run task 1 every half a second and task 1 every 1 second. Task 1 would probably happen before task 2, but as soon as task 1 was done, task 2 would go. So it tries its best to keep the timing.
Okay, but it's done by the system.
It's done by the system, yeah. Yeah, so we just say priority, which we're probably going to keep fairly general, like maybe 3 priorities, most of the stuff running at low priority so that we're always like ready for something high priority to come in. Something like that. That's going to be something we need to experiment with a lot. Yeah, we'll have to see. So we don't have much running right now. You hear about people using like hundreds of tasks and stuff running all at once. I don't think it'll be that crazy, but it'll be tens for sure. Okay, so we've created this task. That's good. And the rest of this stuff we don't need to touch. So we've added our task to the scheduler, so that's the first step. So let's see in here. Priority, we can just leave it at 4, which is what it was. Now what you do is, this is where you define the function that your task is going to run. So the RTOS stuff is just sort of a harness around a normal function. And I'll just go see what I actually called that. This is C actually. So you don't get any objects, which is too bad. And you got to deal with C strings. I've looked into moving it to C++, and it's possible. Like you can compile it, but I've heard there are some issues with using the RTOS plus the C++ at the same time. So like you can get around it, people do it, but I think it might be just a little bit of awkwardness. Because we've been fine with C so far. But if that's something someone wants to look into, I'm down. Objects are nice. It's C++, but you don't get classes. Really, that's the main difference that you run across. All the rules other than that are the same as far as I'm concerned.
Well, it's only good for like second year.
Yeah, and then you can say you're hardcore because you write C. Yeah. Okay, so that's good. So that is saved. Now we have SFU tasks. So we're going to break this into multiple files, I'm sure, because this is just, like, there's a ton of stuff in here. But let's copy this convenient demo ADC task that it has found. Didn't know that was there. And we'll remove everything except like the main structure, and then we'll redo it. So, and we gotta call that something. Is this helpful? Or is this just me talking? I hope it's sort of helpful. Well, there's going to be a video, so you can listen to me talking whenever you want. Okay, so we actually need that. So we'll delete all this stuff pretty much. Might need to come back to that. So the function that your task runs always looks like this. So you initialize any variables that you need to stick around, and then you have a forever loop, and that's just how the RTOS wants you or needs you to have things done. So what'll happen is when this task is called, it'll like set stuff up, and then it'll go here, run anything in here, and then typically what you'll do once you're done running your stuff once is, actually we don't do it here, you'll say like task delay, and then that will just let control back to the RTOS for a bit, and then it'll rerun this task in 2 seconds for this one. So let's bring that in there too. Okay. So put that at the bottom. That's good. Sure, we'll run every 2 seconds, that's fine. Okay, so now we need to actually read the ADC and stuff. And we now have a couple folders called test sequences and unit tests. So test sequences will be like a whole pile of RTOS tasks and whatnot, things like we did for the Triumph test, which the code is all sort of scattered in here already. But what I'm going to do is break that out so that it's all sort of one or a couple functions that you just pop in there, and then it will start running that test. Because there's a lot of good example stuff in there, a lot of bad example stuff too, actually. But the unit tests are for things like hardware, so just how to run an ADC, and I've only got like one in there right now, but these are sort of the tutorials and really explain how to do everything. And so when we discover how to use usually like hardware features like an ADC, we're going to create a test like this, just as an easy example of how to use it. So first thing we need to do is init ADC test. And so we need to put that in main alongside all of the other inits that we have. So that's good. Actually, let's not, yeah, we'll do that. Let's do that. And we'll go back to that test. Okay, yeah, actually this is, yeah, I can see how we'll do this example, that's good. So this function, we'll just walk through it. So we're going to say like expected output is some kind of value. That's like obvious. And then I've said an easy way to test this is to query channel 2, which is connected to the current monitor. So that'll like give us a value other than 0, so we can at least check that things are actually working. And then grounding an ADC pin will give a 0. So we have various ADCs broken out to here on the 104 connector. You can use those for sure. And there's a spreadsheet that describes where they're all connected. So that'll come into play like when we're writing the task to deal with the RF ADCs. But they're good for testing too because you just plug something in. So anyway, the one is like the one we're going to use is connected on the board, so we don't need to plug anything in. So this is some example stuff. So the way this works is this example code here came from a Halcogen example. So these are another useful resource if you're dealing with hardware, which you probably will at some point. Like most of the drivers are done-ish, but this could be good. And like for Lana doing the I2C driver, the example code is a good place to start. So for me, it's under TI, so it's under wherever you put Halcogen, probably a TI folder like this, and then examples somewhere. Examples, there it is. And then chip-wise, for this, pick 09 or 07. And then it's got a bunch of C files. So if you're on Windows, you can actually go in the Halcogen help, and it will like pop up a little window with like a tutorial with some pictures and stuff. Doesn't work under Wine, unfortunately, but the C files have all the comments that like help window is created out of, so you can usually figure it out. And you could like find these pictures if you wanted to; they're buried somewhere. But these are generally like pretty good and easy to use. So that's where the example code for the ADC came from. Is really kind of what I'm getting at. So it's like where to find that resource. So we'll go back to that. So when we run this task, all it does is we give it the channel we want to look at. It will run the conversion on the ADC. So it'll sample all of the channels in this group, and you assign the channels to a group in Halcogen, and we can look at that a bit later, I think. Then, this is not the best way to do it, but this is what the test does, is we just wait for the conversion to complete. So we'll eventually get around this by doing some RTOS stuff, which we can get into later a bit, maybe if we have time. Also, I don't remember too much of it, but anyway. Then we grab the data. This doesn't actually get used. The data goes into this array of structs, and we just pull out the value field for the channel that we requested, and that just comes back to us. So I think the way we'll just test this is we'll throw a breakpoint. Actually, we'll throw a breakpoint in the function. So so go back to our task here. So we can actually, let's just comment that out. So that's command or control / we'll comment stuff. So we have a variable to hold our ADC result. Value equals test ADC, and then we got to fill in the channel number. Let's do channel 2. And what we'll do is we'll throw a breakpoint at the task delay. So when this task runs, it's going to do the test. So it's going to get this value for ADC channel 2. And since we're waiting here, this value will already be set, so we can go look at what it is. So that should be good to go, I hope.
Can you write code, or like, can you only write code when the board is running?
No, you can write code with nothing plugged in.
Okay.
Yeah. But we're going to debug it to look at this value. It's just the easiest way. So we'll hit debug now, and it'll build. We'll see if it gives any errors. It's asking if we want to stop debugging to do that, then say yes. Oh, actually, it's going to give us an error, I'm pretty sure. It should. Maybe not. Okay. Oh, it didn't. Now, I am a bit skeptical that this will run because we didn't include the ADC header in that task file. It might go. It might make its way through. We'll see. So anyway, we've got that breakpoint there, so it should stop. So stop there, good. And it's going to set stuff up. Okay, actually, so it did stop at our task. So you, when you're debugging, you can look at variables. So it'll throw everything that's kind of current in this variables tab here, which you get at from like window variables or something like that, if it's not there. You can also add a watch expression, which doesn't always work for me, but it's supposed to update continuously. So actually this should stay pretty constant, but it might come back, I don't know. No. Actually, yeah, for something to update continuously, I think it needs to be a global variable, which kind of makes sense. But anyway, so you can see we got 628, which just from experience is sort of pretty much what it should be. So we've created a task to read the ADC so far, so that's good. What else can we do?
The value ended up being the drop.
So
Yeah.
it continuously just reads the ADC, and then it delays.
So yeah, so it runs this task. It'll read it once, and then we put this task on the shelf for 2 seconds, and then we read it again.
Okay, and then how does the RTOS get out of the task? Because it's like infinite loop, right?
The RTOS gets out of the task when it sees this. So things like VTask delay are just RTOS magic. I don't know how they work, but they do.
Oh, and then that tells the RTOS to look for the next task?
Yeah. So the RTOS is very frequently looking to see if it's running the correct thing, and so that's VTask delay is probably not actually a function. These tend to be macros. It might be a function. I don't know. They flip flop a lot, but yeah, there's some stuff happening in there that's telling the RTOS like, okay, this task is done. Don't worry about it for 2 seconds. And the RTOS always knows what time it is. So that's how, like, the first way it keeps track of that. So it'll say, like, okay, in 2 seconds I need to evaluate whether I should run that task or not. When those 2 seconds arrive, it will see, okay, this is probably the highest priority thing that's sort of ready to go that needs to be run at this time. So I'll run it now. So yeah, there's magic behind the scenes in terms of how it actually does it. But the main thing to know is when you run like VTask delay or something like that, it will start back up at the top of your while loop. I think you can actually also do, like, have multiple of those. So like, think about it this way. It's hitting VTask delay, and then it's coming back to the next line, which would send us up, in this case, to the top of the while loop. If we had VTask delay, and then some other stuff below it, and then another delay, I'm pretty sure it'll just run the stuff below it, hit the other delay, and then it would head back up. We could try that, actually. Let's try it. So we'll use the debugger because it's the easiest way to experiment. So let's so we'll set thing equal to 0 right now, and then we'll wait 2 seconds. We'll set thing equal to something large, and then throw another delay in there. Should do it. We'll just breakpoint there. The other thing is, when you're debugging, it won't always let you add breakpoints as it's running. So you can just hit pause or stop since we added code. Yeah. So I'll just slam a breakpoint right there. I'll save it. We'll do it there too, so we can see it update. Look at debug. So this is good that this happened. This comes up sometimes. It goes into like an abort interrupt when you kill a debug session. So what you need to do in that case is these two buttons are like reset and then go back to start. Just sort of mash those a bit, and then eventually it'll go back up to main. So that's what you want. Yeah. just hit those in some order. It won't damage anything, and eventually it'll work. Okay, so we started. So we should see it. Okay, so we got that ADC. So you can see it's slightly different now. That's just because we're measuring the current, and that's like constantly changing as it's computing stuff. So that's
Should the thing
good.
be there too? Or those are just wedge impressions?
Yeah, it should be in variables. Yeah, okay, so it's 0. So we'll see if this worked. So if it worked, wait, in 2 seconds it'll come back and it'll be 3242. I think it does this. Yeah. So if you need to, you can do something along these lines where do something, let's say you know it's going to take a little while to happen, like actually reading the ADC. You can throw a delay in there and then just come back to it. That could work. A bit hacky, but it's alright. Okay, so things I said I was going to show. So that's like a very basic task, but also how to use the debugger to just see if things are actually working. So that's stuff you're going to do a lot. Anyone have any questions on that?
What functionality does the JavaScript get then? Is it just a breakpoint? So
yeah.
The ID, which is like just code composer, right?
Yeah.
And then is it just breakpoints?
So it's breakpoints and the ability to just program the chip in general. Like we can't do that over USB. Yeah, they make it really hard to program microcontrollers. Like you can get for like low end micros, you can get just a programmer. It won't give you the debug capability. But for ones like this, you pretty much to program it, your debugger has programming and your programmers have debugging. So you really just need something like that anyway.
So everything you just did wouldn't have been able to be done unless you had the JVM. Like if you just had to plug into visual speed.
Correct.
You wouldn't have been able to run anything.
Correct.
Okay,
Yeah.
okay.
Yeah. So the USB is just sending commands power, and sending commands in and data coming out, just for us to monitor stuff. Yeah, we can't program it over that. Yeah, it's a lot more stuff to be able to program over just straight USB, and we definitely couldn't do debug over it. So yeah, that's why we gave it JLink. Yeah, and I think there are probably a lot more debug functionalities that I don't really know about. Yeah. Yeah, that's a good question. So let's see. What can we go over? We could try and print the ADC value. This gets to be tricky.
Can I ask a question? Where do you register all the tasks?
So that happened in task main. So the first thing you do is you create the handle here.
Okay.
And then that's just something the RTOS needs. You never really see it outside of, well, you don't see it at all outside of RTOS things.
So that is the only place where you say that here's the task I want you to be calling.
So it's sort of like three things. So you create the handle.
Mhm.
That's just a thing the RTOS needs.
Mhm.
You actually create the task. So this sets it running.
Okay.
And the function that the task is actually running is, well, we added it to the SFU tasks header, and it's defined in tasks.c. So yeah, it's sort of four things. It's a good question too. Okay. Yeah, let's maybe try and print this value out. So we'll take a look at what we did last time, because this gets tricky. This is where you get into like C grossness. So the sending stuff to the UART, like out to us, are strings which are ASCII. So if you just send, say the variable was 342, well, ASCII only goes up to 256, so that would cause you issues anyway. If you try to send out like 28 or something like that, that would give you like an A or whatever that is. So you got to do some stuff to convert your integer into ASCII. Where is this done? I had this done before. And this is where Stack Overflow comes in. Flash read. Flash read 16.
That's why I went with like the odd income records.
Okay, that's the current one. Oh yeah, it's under it. Okay, so we get that. That's the value. Okay. Yeah. So the trick for this one is I to A. Should be I to A. It means integer to ASCII. Yeah. Okay. So we'll just copy all this stuff for now, and we'll go through it.
Hey, but it's in the day. What if you buy it on the spot? What does it cost? You can actually buy that.
So
It's like $400.
this is right.
Yeah, I mean, unless it's useful, and once buy it, you want to basic, right? So someone $10.
So yeah, a lot of copy and paste. Okay, so what do we do here? So we create a character buffer. So if you need to send strings out over that, not too bad. There are examples of how to do that. If you want to send anything more complicated, you need to like construct it and then throw it out. So we'll try this out. So we created the buffer value. Let's rename that. So we go to character. So I wouldn't be too concerned about this. We'll just see if we can get it to work. So we add that. Okay. Well, we'll see how this goes. Sorry. But this would be a good place where we should have a function to do this crap for us instead of copying this over again. So, room for improvement for sure. So we'll see if it builds if I copied everything right. Wow, it worked. Okay. Okay, so. But yeah, main takeaway from that is copy stuff. Yeah, okay. So there's some weirdness happening because it printed out a bunch of garbage after, but it did print the correct value, I believe anyway. Send value. Yeah. So it printed 649, so could be worse, yeah. So there's some business happening where no, it's so we had the buffer was 10 characters and they're uninitialized. So yeah, so we're throwing the proper value into the first few, and then the rest are just whatever. So it's getting that out there. So that's fine. If we wanted to initialize all those to 0, we could do that. Or empty character, we could do that. But that does work, so that's not too bad. So you can remove breakpoints if you're like paused, and then you can hit play again, and you'll see it'll print one of those every 4 seconds or so. Yeah, 575 now. Some garbage. 564. So that's how to do a task. And how to print a bunch of trash out of here.
So normally you just do like a space.
Yeah. So we should definitely make that easier to do. But yeah, you'd initialize that array as empty characters, fill in what you need, and then ideally your array would be just big enough to hold what you need. But what if it was 4 digits instead of 3? So you gotta worry about stuff like that.
Is there like length options? Like, could you just do like this variable and the size of the
That's a good question. That brings up a really good hole with C, and this is something Steve and I ran into a while ago, and we were like scratching our heads about it. You can't. So let's say we could determine the number of characters of that value. Say over 999, then it's 4 characters. Under, it's going to be 3 or whatever. You can't put a variable here when you're initializing an array. It has to be a value or static, whatever the hell they call it. Just a number there. You can't do a variable.
Could you have a dynamic buffer?
How do you do those?
Well, instead of just saying it's a buffer, you can put a pointer to it. Isn't that how you make
I guess so.
dynamic arrays in C?
Yeah, I don't know much about dynamic arrays in C.
Yeah, I'm pretty sure if you just initialize it as a pointer, then you can put variables as a size.
But how could you not how do you know where the end of that is? Because what if it's you end up putting more stuff at it, and then it overwrites into your can you do that in C? Because the whole point is that it needs to know how much memory to allocate and where to put it so it doesn't run into anything else. There might be a better way. I'm not sure.
You can just have more control over memory use.
Yeah, it's not
there we
really
go.
better.
I found your answer.
Yeah.
Dynamic array implementations work by starting off with an array of some small default size, and then whenever you run out of space when adding a
you
new
like
element,
memcopy and stuff?
double the size of the array.
Okay.
There you go.
Okay, so there's a better way to do it. But that's also inefficient.
Yeah,
Yeah, you could argue either way. Yeah.
I mean, you
Something
can do
like
it.
this, I'd probably just make it 4 because I know I'm not going to be over 4.
Yeah, but then if you don't really know.
Yeah. It's very, very application specific for sure. That's good though. Yeah, okay, double it. That makes sense. That could get huge. Yeah, but then that'd be slow, so, trade-offs. Yeah, trade-offs. But, I
It's
mean,
also going to be smart how you you need to think about increasing arrays.
yeah, for sure. And, the one thing is, we have computing power to spare, so we don't need to be too concerned about speed. If you want to iterate through something, go for it. Yeah, those are the kind of challenges that come up. Things like that.
I'm gonna head out.
Okay, yeah, man. No worries. I think we're about done for what I can talk about. I don't remember any of this. Any questions?
What is
Pardon me? Channel 2, so that corresponds to just a pin on the chip, and we've connected that up to the current monitor chip as an output. Yeah, so it's just straight up connected to something that's always going to be changing a little bit. I'll have to look into the dynamic buffer stuff.
I'm listening to music.
Huh?
If I'm listening to music.
Yo, I quit FCFO, so I'm not liable.
Yeah. That's all I have to say.
So what if you don't want this thing to happen repetitively? What if you just want it? Well, I guess you do initialization.
Okay, yeah. You can. So let's say we want to just run this thing once. What we do there is, I believe. It's like vtask suspend or vtask delete.
Okay.
Yeah, you'd run one of those.
What if after some event happened in a different task, you want to stop running one task altogether? That's what you can use?
No, for that you would do, you'd probably have a semaphore, or, which is like a flag.
Yeah.
Yeah, okay. So your task you want to delete or whatever when that happened would be looking for that semaphore, and then when it came in, you'd probably run vtask delete.
Okay.
Something like that.
Yeah.
Yeah.
Go.
Yep. Yeah, hit me with questions. Quiz me. It's been a while.
Why do you not ident your stuff within the while loop?
It should have been indented.
It should have been.
I missed.
Yeah, I don't have any more questions.
Okay. Yeah, I just run auto indent before
that's fair.
pushing. Yeah. Probably.
That could be like one of those pivot if it's not working out. I'm telling you, why do that?
Done, I guess we're done.
Okay.
What is meant by debugging of embedded software on actual hardware?
Honestly, I think
This.
that might
This
be
is
like.
what you
Yeah.
I add that to my resume.
Are these like interview questions?
No, it's requirements for
Oh.
job description of
Where?
Magic.
Oh, okay.
It's embedded software stuff. I thought it was legitimate. It just says enjoys hardware and software. I was like, I know how to software debug. I'm pretty sure I might learn how to hardware debug. So
Well, by hardware debugging, they probably mean like
PCB
something's
stuff?
not connected. Yeah.
Okay, I also.
You did not get there yet.
It's
Oh,
like it's ready
yeah.
running for you.
No, yeah, kind of.
Yeah.
Just these
That's a
like,
pain.
circuits.
Hardware debugging is a nightmare.
Yes.
That's like a Kickstarter type of thing.
You screw up the button footprint, and it causes it to stay in reset. And you know that you screwed the button footprint up. You just didn't realize that that's what the problem was. You wasted like a month.
So it's just like PCB layout.
Yeah, yeah. So it was like the pins were connected or should be connected diagonally. So like it's like 1, 2's down here, 3, 4, and I had 1 and 2 right beside each other or something like that. And just the way it was shorted out constantly, so it was holding it down into reset.
Oh, wait, did that take you guys?
It was just me because Steven was gone. Took me a month. And I knew
Didn't
from
tell
like day
Steven about
2 that I screwed the button footprint up because I was probing around. I was like, oh shit, that's not right. And then I kind of forgot about it and didn't realize that that's what was happening. Yeah. Well, and, I mean, that was only one of the issues. The first thing we had was there wasn't software support for the J-Link and the specific chip we're using. So we had to get them to add it. Like, the J-Link has everything except the one that we needed, of course. But that only took a couple weeks. They just posted in the forums. I was impressed at how good they were at that. But, I mean, they do owe us with 5 of them. We spent hundreds of dollars on their chips, so it's worth them to send a couple emails. So, yeah. That's the thing, like, you sort of don't realize that you're eligible for vendor support, but we bought their parts, so we're totally eligible. So, yeah, the TI forums.
In my second year, I took 20 in the summer.
I felt like I didn't write anything tangible.
Expecting we might need to do a lot of forum posting for the low power stuff. 'Cause, yeah, as
Was that code that we found?
I haven't looked at it too in depth. I'm sure it will be, but I was just sort of doing some random googling, and I found a lot of like very buried forum posts that weren't on the sheet that you guys made, and it was people having all sorts of weird problems and just like things to consider. So that's gonna be a big one. So, yeah, there's no app note on the low power stuff, which is really too bad. And like using it with the RTOS and stuff like that.
Right.
But yeah, I'll see what that code says and stuff. I was just sort of doing more resource collection for when it inevitably dies. Yeah. But yeah, we'll work on that one pretty soon.
Cool.
So that's a big one to get out of the way. How's your setup going?
It's not. I'll try, I just find it so ridiculous. Like, even like the demo project that comes with FreeRTOS is not working.
The one that started in Halcogen? Or just a free RTOS one?
Just the FreeRTOS one.
Okay.
I'll try.